All right, here we go. Page 5, Unit 8, test review. We are almost done. Last page. Here we go. Diagonals of a rhombus, all right, are 4 and 4 square root of 3. All right, find the perimeter. First things first, it's a rhombus. Draw a picture, guys. All right, you have plenty of room. Draw a picture. All right, and again, what is a rhombus? What does it mean to be a rhombus? All right, what are some properties? What is the definition of a rhombus? A rhombus is a four-sided shape where all four sides are congruent. All right, so that's what we have. Now, we have a diagonal and we have another diagonal. The diagonals in a rhombus are perpendicular. That is going to be very useful for this problem. All right, now they tell us that one of the diagonals is 4 square root of 3. All right, so I kind of ran out of room, so I'm going to write this on the outside. 4 square root of 3. All right, so let's try that again. 4 square root of 3. That's this entire, top and bottom, right? The other one is just 4 to the left and to the right. Now, since this is a rhombus, it's also a parallelogram. All right. We know that in a parallelogram, in every parallelogram, the diagonals bisect each other. All right. So they cut each other in half. All right. So we could do something like that. Now, we could prove pretty easily that all four of those triangles, you have four small triangles on the side, they're all congruent, right? You can use the side theorem, side angle side, HL, right? What have you. Lots of different ways that we could prove that. So here's what I'm going to do. I'm going to pick one of them, right? I'm going to pick this guy up here, and I'm just going to redraw it. All right, I'll draw it a little bit bigger. So this is a right triangle, right? Now, since the diagonals bisect each other, I know that this piece right here is just half of that entire vertical piece. So this is 2 square root of 3. All right. Similarly, I know this horizontal piece is just half of 4. So it's going to be 2. All right. Now, I have two sides of a right triangle. How do I find the third? We're going to use the Pythagorean theorem. All right. So I'm going to call this C. So I know 2 squared plus 2 square root of 3 squared equals C squared. All right, and there we have it. Let's go ahead and do that. I got 4 plus, all right, I'm going to do this one off to the side. What does it mean to square something? All right, to square something means multiply it by itself. So 2 square root of 3 squared is just 2 square root of 3 times 2 square root of 3. I'm going to rearrange these terms. I'm going to have 2 times 2 is 4. Square root of 3 times the square root of 3 is just a normal 3, and this is going to give me a 12. All right, so this is going to be 4 plus 12 equals C squared. That means we're going to have 16 equals C squared. Therefore, C equals 4. All right, so equals 4. Well, hey, guess what? That means all 4 of these equal 4. All right, so what is the perimeter? The perimeter is just 4 plus 4 plus 4 plus 4, which of course is 16. Right? And that one's done. All right. If you wanted, so don't let that, 2 squared to 3 throw you off. If you just want to throw it all in your calculator, by all means, do that. We got 2. Well, here, let's do some print. Come on, get out of here. We have 2 square root of 3. Right, close up the parenthesis, square it, right, and that should give you 12, which is what we got, right? So you can always, fall back on your calculator if you need it, right? Try to try to not use them, but it's there. All right, next one. Word problem. You guys hate these things, but I love them. All right, so let's see you suffer on this one. The longer side of a parallelogram is 10 less than 3 times the shorter side. All right, if the perimeter is 60 centimeters, determine the length of the sides of the parallelogram. All right, so again, parallelogram, draw a picture. Let's start there. All right, so it'll look more or less something like that. All right, now the longer side is 10 less than 3 times the shorter side. What I would always do in these, find the shorter side, call it X. Okay, the shortest side here is going to be X. Now, we know that it's parallelogram, so the opposite sides are congruent. So the left and the right sides on this are going to both be x. Now, how do you say 10 less than 3 times the shorter side? All right, so 3 times the shorter side is 3x. All right, but we have 10 less than that, so I'm going to subtract a 10 off of here. So I get a 3x minus 10 on top and a 3x minus 10 on the bottom. All right. Determine the side lengths. Okay, they give us the perimeter. So remember, the perimeter is all 4 sides added together. So what we're going to have here is x plus 3x minus 10 plus 3x minus 10. All right. You add all that together, it equals 60. All right, so let's just go ahead and do that. How many x's we got? 6, 7, 8. You got 8x minus 20 equals 60. 8x equals 80. X is going to equal 10 here. All right, we're not done. That was the hard part. Do not skip the easy parts. All right, they want us to find the lengths of the sides. All right, plug it in. All right, so this piece right here, 3 times 10 is 30, minus 10 is 20. All right, so we have 20 on top and on bottom. All right. The other side, wait a minute. Yeah, that's right. The other side, that's just going to be 10. All right, so the left and the right are 10. And if you want to check, add up all of those side lengths. 10 plus 10 plus 20 plus 20 is 60. So that works out. Right? And that's how we do that problem. All right, so again, draw pictures on these. That's going to be, very helpful. All right. Oh, time for the proofs. The dreaded proofs. You're going to have one of these on your test. It's kind of like a half proof, though. I think I give you all the given or the statements. You got to fill out the reasons. I can't remember exactly what it looks like, but it's going to be something of that magnitude here. So we have our statements. I'm going to go ahead and abbreviate that. We have our statements. We have our reasons. We're going to make our T-chart, and we're going to see what happens. I don't know what I just did. All right, what is going on here? Step 1, I was given information. All right, so P, Q, R, S is I'm going to abbreviate, parallelogram. All right, we also know PJ is congruent to RK. All right, that's all given. All right, let's see here. So let's go ahead and highlight that. So PQRS, that's the whole outside shape right here. Now, what they did is they gave us a lot of free stuff. All right. They told us the top and bottom are parallel. The top and bottom are congruent. The left and right are parallel. The left and right are congruent. The diagonals bisect. The opposite angles are congruent, right? So they said all of that with that single word right there. So knowing all those properties is really going to help us finish out this proof. What we are trying to do is we are trying to show that Sj is congruent to KQ. All right. So how can we do that? Well, let's look at this one. Those two are congruent, so that's kind of nice. Here's what I'm going to say. I'm going to say step 2. All right. I know that SP is congruent to RQ. And how do I know that? Again, I know that because opposite sides, I'm going to do a lot of abbreviating here. Opposite sides are congruent in a parallelogram. All right. So here's what we got. I'm going to do one of these and do one of those. All right. Now, the next thing I'm going to do is I'm going to say step 3. Angle P is congruent to that top corner there, which is angle R. All right, so some of you might see where I'm going from here. All right, and again, I know this is true because those opposite angles are congruent in a parallelogram. All right, so I'm gonna put some arcs on here. All right, and then let's look at these triangles. What can we say about these two triangles here? Turns out that they are congruent. You got a side angle, side triangle going on here. So I'm going to say SPJ. So step 4, triangle SPJ is congruent to SPJ is going to go with, remember the order does matter. So S to P to J is going to have to go QRK. Triangle QRK. All right, I know that from the side angle side theorem. There's a unit 4 throwback, right? So it's really going to, pay to remember all that older stuff. All right, and then from here, we automatically know what the next reason is going to be, right? Anytime you do a triangle congruence, you're always going to throw down CP, CTC, right? Those corresponding parts of the congruent triangles are congruent, right? So we know the green triangles are congruent, therefore all the matching pieces have to be congruent. Well, look, SJ matches up with QK, so we know that those must be congruent. SJ is congruent to QK, or I guess KQ, doesn't really matter. All right, and we know that from the CP-CTC theorem. Right, and that one's done. So that was a quick little 5-step proof. All right. Let's finish strong here. Last one. ABCD is a rectangle. ABTC is a parallelogram. I want to show that angle 1 and 2 are congruent. I think this was a homework problem. So it might have been a quiz question. I don't remember. But there's a ton of ways to do this one. All right, so for the half dozen of you that watch this video, if you do something different, it does not mean you are wrong, all right? If you want me to check it, I'm more than happy to do that. But just know the way I do it might be totally different from the way that you guys do it. And so you got all your given information. All right, again, ton of stuff there. So rectangle, parallelogram, that gives us so much stuff here. So I'm going to do one of these, just highlight it all in red. And then the other one is the parallelogram. That's going to be this guy right here. All right. We want to show, what do we want to show? We want to show that angle 1 and angle 2 are congruent. All right. How do we want to go about doing this one? I'm going to go with the shortest way that I see. All right. So step 1, or I guess step 2. I'm going to say DB. DB is congruent to AC. All right. And I know diagonals are congruent in a rectangle. So those two are congruent. All right. Now, what I'm going to do is I'm going to say, all right, well, I know that AC is congruent to BT. No, yeah, I'm going to say that BT. All right. And I know that one because those are opposite sides in a parallelogram. And I know the opposite sides in a parallelogram are congruent. Forgive my handwriting here. All right. Opposite sides are congruent in a parallelogram. Let me fix that. Writing on a screen is not easy. All right. Step 4. I'm going to say using the transitive property. All right, let's look at this. I know DB is congruent to AC. All right, that was step 2. I know AC is congruent to BT. That was step 3. So I can use the transitive property here, all right, to just say DB is congruent to BT. All right, so how do we know that? Again, that's the transitive property. All right, so there's something way back in unit 2. All right, now let's look at this triangle. That triangle that I just drew, we just showed that these two sides are congruent, right? DB and BT. So what I can say is I can say, well, look at that triangle. Triangle, I need to name this thing. How about DBT? Triangle DBT is isosceles. And I know it's isosceles because we have two congruent sides, right? That is useful because now, anytime I have an isosceles triangle, I have two congruent sides. That means I automatically get two congruent angles. All right, so we can finish this one up. And I can say, all right, well, angle 1 is congruent to angle 2. Why is that? I'm going to say two congruent angles in an isosceles triangle. I'm going to abbreviate. All right. And that one's finished. All right, I think I did everything I needed to there. Another way, there's a lot of ways you could do this one. Like you could, I'm just going to clear this out. You could say something like, hey, these two angles are congruent, right? Those are opposite angles. If you wanted to, you could show me that these two triangles right here are congruent, and then you could use CP/CTC to, get that top angle and angle 2 are congruent, transitive property to tie angle 1 and angle 2 together. There's a lot of different ways you could do this. You could say angle ACD is corresponding with BTC, and then show that the bottom purple triangle is an isosceles, so that angle 2 and angle ACD are equal transitive property. Put those together, right? Lots of different ways to do this one. All right, so is my way the best way? Probably, maybe, I don't know. I don't know if, you could do this in less than 6 steps, but, that just goes to show that, there's lots of ways to do these problems. All right. So there we have it. That was our Unit 8 test review. Like, comment, subscribe. See you guys later.